Have you ever held something weighing less than 2 grams and wondered if it might be one of the most important objects ever created by human beings? Did you know that a product used for mere minutes takes nearly 3 full days to manufacture? Did you know it undergoes more quality tests than the steel cables holding up a suspension bridge? Did you know it can stretch to 800% of its original size without tearing? And here is the question that should truly stop you. Did you know this tiny foil-wrapped object has prevented more deaths in the last 50 years than almost any medicine ever invented? We are talking about the condom, the most used, least discussed, most misunderstood manufactured object on the planet. Today, we go inside the factory. We follow every step, from a drop of white liquid on a rubber tree in a tropical forest to a perfectly sealed packet on a pharmacy shelf halfway across the world. By the time this journey ends, you will never look at that small foil square the same way again. Before we step onto the factory floor, we need to go back. Not decades, not centuries, thousands of years. The earliest depictions believed to show condom use appear in cave paintings in Camberels, France, estimated to be 12,000 years old. Before writing, before agriculture, before the wheel, human beings were already thinking about protection. Ancient Egyptians used linen sheaths as early as 1000 BCE. Romans and Greeks used animal bladders and intestinal tissue. In 15th century Japan and China, people used oiled silk paper as barrier protection. The real turning point came in the 16th century, when syphilis tore through Europe like a catastrophe, killing kings and commoners equally. Italian physician Gabriele Falloppio documented clinical trials of a linen condom on over 1,000 men. His claimed success rate against syphilis? 100%. For 2 centuries after, condoms were made from sheep intestine, soaked, scraped, dried, and tied with ribbon. Reusable, expensive, effective. Then, in 1839, Charles Goodyear, yes, the tire company name, accidentally discovered vulcanization, a chemical process transforming raw rubber into a durable, elastic material. By the 1860s, rubber condoms were being mass-produced for the first time. Then, in 1920, chemist Julius Fromm pioneered dipping glass molds directly into liquid latex, producing a thinner, smoother, single-use condom at industrial speed. That fundamental method, dipping a glass former into liquid latex, is still the foundation of how every condom in the world is made today. From animal intestines to industrial chemistry, the condom's history is the story of human problem-solving at its most critical. Every condom begins not in a factory, but in a forest, specifically in the rubber tree plantations of Southeast Asia. Malaysia, Thailand, and Indonesia together supply the majority of the world's natural latex. The tree is Hevea brasiliensis. Originally from the Amazon, transplanted to Asia in the 19th century, it now supports an industry worth hundreds of billions of dollars. Harvesting latex is called tapping. A skilled worker makes a precise diagonal cut in the bark. Too shallow, nothing comes out. Too deep, the tree is permanently damaged. From that cut, a milky white liquid seeps out and drips into a small cup. That liquid is natural latex. A single tree produces roughly 100 milliliters per day, half a cup. Collected each morning, mixed with ammonia to prevent coagulation, and transported by tanker to processing facilities, where it is filtered, concentrated, and tested against strict quality standards. Any batch that doesn't meet every requirement is rejected entirely. There is no compromising on the foundation of this product. When qualified latex arrives at the condom factory, it doesn't go straight to production, it goes to the compounding room, and this is where chemistry becomes something almost like alchemy. Raw latex alone would make a terrible condom, too fragile, too sticky, degrading within weeks. Manufacturers blend it with a carefully formulated mixture of additives that transform it into the precise material required.
These include sulfur and zinc oxide, vulcanizing agents that later create the molecular bonds giving rubber its elasticity. Chemical accelerants speed up that process. Antioxidants extend shelf life. Stabilizers prevent premature reactions. This mixture is stirred for hours in large tanks. The specific ratios of each ingredient are among the most closely guarded trade secrets in manufacturing. They determine the feel, strength, stretch, and shelf life of the finished product. Different brands, different formulas, fundamentally different results. The compound then rests in holding tanks during pre-vulcanization, a controlled, timed phase where molecules begin forming initial bonds. The compound is ready. The production line is waiting. Now we arrive at the most extraordinary sight in the entire factory, the dipping line. Picture a production hall the size of several tennis courts with precisely controlled temperature and humidity. Running through this hall in a continuous loop are hundreds of glass formers, molds shaped exactly like the human anatomy they are designed to fit. Glass is used because it is smooth, chemically inert, non-porous, and easy to sterilize. They move in an endless mechanical procession through every stage of production. First, each former is washed and rinsed to absolute cleanliness. A single microscopic particle of dust on the surface creates a flaw in the finished product. Next, the clean formers are dipped into a coagulant bath, a solution of calcium nitrate. This coats the glass with an invisible chemical film. When the coated former is then immersed in latex compound, a reaction occurs instantly. The calcium nitrate causes the latex to gel and adhere uniformly to the glass. This is the first dip. A thin, even film of latex coats the former. The former moves into a drying oven. The first layer sets. Then a second dip, another drying cycle, then a third. Most standard condoms require 3 to 5 complete dip and dry cycles. Ultra-thin condoms use more dips of a thinner compound. Extra-strength varieties receive additional cycles. The final wall thickness? Between 0.04 and 0.09 millimeters. A standard sheet of printing paper is 0.1 millimeters. The condom in your hand is thinner than paper, and yet can withstand forces that seem almost impossible. After the final dip, formers pass through bead rolling. The open end is rolled to create the rim. That thick ring at the base allows proper unrolling during use. Without it, application would be almost impossible. The latex-coated formers now enter vulcanization ovens, tunnel-like chambers heated to between 100 and 130 degrees Celsius. Inside, the chemistry set in motion during compounding completes itself. Sulfur compounds react under heat to form crosslinks, molecular bridges between rubber polymer chains. Before vulcanization, the latex film is weak. After vulcanization, it becomes the extraordinarily strong, elastic material we associate with rubber. Here is that number in full. A properly vulcanized latex condom stretches to 800% of its original length before breaking. That is not a marketing claim. It is a measurable, internationally standardized physical property. The molecular architecture created by heat and sulfur make this possible. When formers cool after the ovens, condoms are removed, a process called stripping. Water jets create hydraulic separation between latex and glass while the condom is carefully rolled free, done without tearing, without distortion. The stripped condoms tumble through warm water baths, washing away every trace of chemical residue from the manufacturing process. The finished product contacts sensitive human tissue. There is zero tolerance for contamination. After washing and drying, most condoms move to lubrication. The most common lubricant is polydimethylsiloxane, a silicone-based compound that is chemically inert, odorless, body-safe, and doesn't degrade the latex during storage. Condoms are tumbled in drums while lubricant is sprayed evenly across all surfaces. Quantity is precisely controlled. Too little affects performance, too much makes packaging messy and application unreliable. This is the part that genuinely shocks most people. Condoms are among the most rigorously tested consumer products manufactured anywhere on Earth. The global standard is ISO 4074, the International Organization for Standardization for Natural Rubber Latex Condoms. Electronic testing, every single unit. Every condom off the line, not a sample, every single one, is placed on a metal former and subjected to high-voltage electric current. Natural latex is an electrical insulator. Any hole, any defect, any pinhole invisible to the eye will allow current to pass through and trigger an alarm. That condom is instantly destroyed. This test detects holes as small as 0.005 millimeters, smaller than a human red blood cell. The inflation test, random samples from each batch are inflated with air until they burst.
The international standard requires a minimum burst volume of 18 liters of air. Quality condoms routinely burst at 35 to 40 liters. The water leak test. Condoms are filled with 300 milliliters of water and examined, sometimes rolled across absorbent paper to detect moisture from invisible micro defects. Tensile strength testing. Strips of material are pulled in calibrated machines until they break. Both force at break and elongation at break must meet international minimums. Accelerated aging. Batches are stored in high-heat, high-humidity chambers simulating years of shelf storage in weeks, predicting real-world performance across the stated shelf life of 3 to 5 years. Any batch failing any test is entirely destroyed. No rework, no second chances. The cause is identified, the process corrected. Condoms passing all tests travel to packaging. Each is individually sealed into a hermetic foil packet, 2 layers of aluminum laminate foil pressed around the condom and heat-sealed along every edge, airtight, moisture-proof. The foil blocks ultraviolet light, which degrades rubber and prevents moisture and contamination. Inside each packet, along with the condom and lubricant, is a small cushion of dry air or nitrogen gas, creating the slight puffiness you feel when squeezing a fresh packet. It's entirely intentional, protecting the folded condom from physical damage during transport. Packages go into cardboard boxes, boxes into shipping cartons, cartons onto pallets, and from temperature-controlled warehouses, they travel to pharmacies, clinics, aid organizations, and distribution centers across every country on Earth. Approximately 10 billion condoms are manufactured every year. Laid end-to-end, they would circle the Earth more than 30 times. A single company, Carex Industries of Malaysia, produces over 8 billion units annually. Malaysia as a whole supplies approximately 60% of the global condom market. The global industry is valued at over $10 billion per year. During COVID-19, when factory shutdowns disrupted supply chains, the United Nations Population Fund raised urgent alarms, warning that shortages could cause a surge in unintended pregnancies and sexually transmitted infections globally. The crisis confirmed what public health experts have known for decades. Condom manufacturing is not a niche industry. It is critical global infrastructure. The World Health Organization states that consistent, correct condom use reduces HIV transmission risk by 80 to 95%. During the AIDS epidemic of the 1980s and 1990s, condom programs prevented millions of infections worldwide. Condoms protect against gonorrhea, syphilis, chlamydia, herpes, and HPV. The United Nations Population Fund distributes over 600 million condoms per year to developing countries, refugee camps, and conflict zones worldwide. So the next time you see that small foil square, think about everything behind it. The rubber tapper working by lamplight before sunrise, the chemist calibrating a formula refined over decades, the glass formers moving in their endless loop, the electricity, the air, the water, the tests every single unit must survive. Think about 10 billion units, 3 days of manufacturing, 800% stretch, a wall thinner than paper, a test detecting holes smaller than a blood cell. Think about the lives protected, the families built on their own terms, the epidemics quietly turned back. The condom is not just a product. It is one of the most precisely engineered, most rigorously tested, and most consequential objects ever manufactured by human hands. From a single drop of latex on a rubber tree at dawn to a foil packet that quietly changed the world.